Heat exchanger are heat-transferring devices, used to move heat from one gaseous, or liquid substance to another for the purpose of either heating or cooling a substance for another process. Constructed with thermally conductive plates or tubes, heat exchanger are used to transfer heat from water to water, air to air, water to air, or steam to other liquids, such as lubrication oil. The objective is to know the type of heat exchanger. Next, to know the heat exchanger flow type and heat exchanger characteristic. Third, to know heat exchanger applications in marine side, and to know the heat exchanger fouling. Tube and shell heat exchanger is the most basic and most common type. Consists of tubes in a container, called a shell. Fluid is separated from the shell side fluid by the tube sheet. Tubes can withstand higher pressure than shells. Support plates act as buffers, directing the flow of fluids. A tubular heat exchanger consists of a set of the tubes bundle typically contained within a shell, thus the name shell and tubes heat exchanger. The tubes contain one fluid, and the second's fluid runs over or around tubes to either supply heat or remove heat from the tube surfaces. Plate heat exchanger consists of plates instead of tubes to separate the hot and cold fluids. Fluids alternate between each of the plates. Baffles direct the flow of fluids between the plates. Plates have a large surface area and provide each of the fluids with an extremely large heat transfer area. Parallel flow heat exchanger is tube side and shell side fluid in the same direction. Fluids enter from same end with large temperature difference. Heat transfer from hotter to cooler. Counterflow heat exchanger is fluids flow in opposite direction and enter at opposite ends. Cooler fluid will approach inlet temperature of the hot fluid. Generally, most efficient type of heat exchanger. Hottest cold fluid temperature can actually be greater than the coldest hot fluid temperature. Cross-flow heat exchanger is fluid flows perpendicular. Usually used when one of the fluids changes phase. Large volumes of vapor may be condensed. Most efficient when comparing heat transfer rate per unit surface area. Regenerative heat exchanger is one fluid is both. It means the fluid can be cooling and cooled fluid, or otherwise. It usually found in high temperature system. The main function is to improve efficiency. Non-regenerative heat exchanger is hot fluid is cooled, or hosted by fluid from separate system. The heat removed, or absorbed is not returned to the system. Single-pass heat exchanger is fluids pass each other once only. Multi-pass heat exchanger is fluids pass each other more than once. Reverse flow in the tubes by use of one or more sets of U-bends in the tube. Heat exchanger are found in most chemical or mechanical system. There is several applications of heat exchanger: air conditioner, radiator, boiler, condenser, preheater, economizer. The deposition of any undesired material on heat transfer surfaces is called fouling. Fouling may significantly impact the thermal and mechanical performance or heat exchanger. Fouling is a dynamic phenomenon which changes with time. Fouling increase the overall thermal resistance and lower the overall heat transfer coefficient of heat exchangers. Fouling also delay fluid flow, accelerates corrosion, and increase pressure drop across heat exchangers. Scaling is the most common type of fouling, and is commonly associated with inverse solubility salt, such as calcium carbonate found in water. Reverse solubility salts becomes less solute as the temperature increase, and thus deposit on the heat exchanger surface. Scale is difficult to remove mechanically, and chemical cleaning may be required. Corrosion fouling is classified as a chemical reaction which involves the heat exchanger tubes. Many metals, copper, and aluminium being specific examples from adherent oxide coatings which serve to passivity the surface, and prevent further corrosion. Chemical reaction fouling involves chemical reactions in the process steam which results in deposition of material in the heat exchanger tubes. A wide range of organic materials are subjected to the problems. Freezing fouling is said to occur when a portion of the hot steam is cooled to near the freezing point for one of its components. This will obstructing both flow and heat transfer. Biological fouling is common where untreated water is used as a coolant steam. Problems range from algae or other microbes to barnacles. Sediments occurs when particles in the solution settle and deposit on the heat transfer surface. Like scale, these deposits may be difficult to remove mechanically depending on their nature. For the conclusion, heat exchanger is very important to transfer heat from machinery, so the machinery can run smooth and for long period without having any problems or fouling. The maintenance also important to avoid any fouling in the heat exchanger, so the heat exchanger will not lose its efficiency. Heat exchanger also have many types and different specifications, so we must recognize all of them to know their conditions and operation.